welcome to your first video under calculus 2. Unfortunately, we have under hyperbolic functions, we have the one under differentiation and the one under integration. But it's so unfortunate that we couldn't tackle the one under the differentiation. So we are going to do it. It will be on calculus 1 playlist and also calculus 2 playlist. Before we bring you the integral calculus, which is the calculus 2. So after this topic, we will be dealing straightforward to integral calculus. All right. Thank you for your understanding and discussion of hyperbolic function. So first of all, let's look at the definitions of hyperbolic functions. For instance, when we say trigonometric functions, it means that we are talking of sine, cosine, we have tan, that is tangent, and the reciprocals of it. Alright. In the same way, when we talk about hyperbolic functions, we are talking about sine, we are talking about cos, we are talking about what? Tangent. Alright. So, we can see that this sine, cos, tangent, and others, for it to make meaning, we have to translate it to what? Natural logarithm. Alright. So with sine is the same as this. So on your calculator, you will not be seeing these functions on it, and it's not the same as sine s is not the same as cos, and sine s is not the same as sine s. Alright. Trigonometric functions is different from hyperbolic functions. So it makes meaning when we translate it this way, and that's it, and that's it. So take note that the sine negative is here, but here there is no negative there, and that is that. So this is the reciprocals of this. We know that tangent is the same as sine s over what? Cos s. Sine s over what? Cos s. So the reciprocal of it will be cos s over what? Sine s, and that is what we have here. So let's see the graphical interpretation. And the graphical interpretation, we know that sine s is the same as half es minus what? Half what? Es. So the positive of it represents the graph on the positive y-axis, and the negative of it represents the graph on the negative what? The negative y-axis. Alright. So this one at the middle represents the sine of what? S. In the same way, when we come to the cos 2, we have cos to be half e power s plus half e power s. Alright. Having that to it should be negative. Alright. Good. Having that to, we know that this one will represent the what? The negative what? 1. In fact, we know that this is what? Acceleration, and it is if it is this way, it is what? Deceleration. So the one going in this way will be what? The acceleration. So that will represent the positive what? 1. And this way will represent the what? The negative what? 1. Okay. So that is the graphical interpretation of what? Cos what? S. Okay. So this is tangent s. Tangent s. Tangent s. And that is the graph of what? Tangent s. Tangent s. This will be a positive 1. This will be a positive 1, and this will be what? A negative. So that is all for the graphical representation of sine s, cos s, and tangent of what? S. Good. Now, let's see if we can solve some examples. Alright, so before we solve the questions, let's look at these identities, and it's very useful as far as this course is concerned. So we have sine. When you plug in a negative value of sine, you get the negative of it, and this is what we call what? The odd. This is odd what? Function. And when you plug in a negative value for cos, you get the output to be what? The positive of what? Of your results. And this is what? Even. This one even. It doesn't matter whether the value is negative or positive, you're going to get it to be what? Positive. Alright. Now, you have to be you have to know how to identify the trigonometric identities to what? Hyperbolic what? Identities. Because we have a trigonometric identity that says that cos square s plus sine square s is equal to 1. But here, hyperbolic is saying that it will be minus. The reason is that in hyperbolic functions, or the identities, anytime if you want to relate it to the trig, it's somehow the same, but when we are having a sine square in hyperbolic, before the sine square, that sign change to what? Opposite of it. That sign change to what? Opposite of it. Or that sign change to what? Negative. So that is why when we are dealing with hyperbolic, here we change to what? Negative. Alright. You can also identify some to where we get to. Here, you see, that will be negative. And look at this one. In trigonometry, I want to relate it, okay? In trig, this is plus. The reason is that, the reason why in hyperbolic we are getting here to be negative is that we know that tan square is the same as what? Tan s is the same as sine s over cos what? S. So tan square s is going to be the same as what? Sine square over what? Cos square. So because sine is squaring here, that is why before it the sign have to change. The sign S-I-G-N have to change towards negative. So you see, this is the same as the one in trig. This is the same as the one in trig. Yeah. Oh no, but here in trig, here is negative. So there is a change here. So you have to take note of it. And there is a change here because of this trinity. But that doesn't mean that this is what? Sine square. Alright. So that is that for trigonometric what? Identities. And here today there is a need to take note of this one. There's a need to take note of that one well. In trigonometry, you get the half angle of this to be 1 minus. But here we are saying the negative 1 plus that of that. Alright. What if in case we have sine 2x? Sorry. Now in trig, we know that sine 2x is equal to what? 2 sine x cos what? S. So let's look at the one in hyperbolic, which is sine 2x. Alright, so sine 2x is also going to be equal to, you see that we know that sine s is equal to this. The angle here is what? S. That's why whenever you see s, you can see the s there. So with this, you can relate. So here you get 2s minus 2s. All this raised to the power of what? 2. Okay. So having this, we can rewrite this as e raised to the power s squared minus e raised to the power s squared. All these over what? 2. We can see that this and this is difference of 2 squares. So we can write this as e raised to the power s minus e raised to the power s, e raised to the power s plus e raised to the power s. And all this is over what? 2. Good. Now, all that we want to do is that we want to relate this in such a way that we can get something like this identities work in. So let's see something. Here we can split e raised to the power s minus e raised to the power s multiplying by e raised to the power s plus e raised to the power negative s. Oh, I'm forgetting something. Here is negative. Here is negative. So here will be negative. Here will be negative. Okay. So here will be negative. Very good. Hope you're not confused. I trust you. You will not be confused. Alright. So we have the whole of this over what? 2. We have the whole of this over what? 2. But I can leave that one here because you have A, B all over C, the same as A, B over C, so no problem with this one. Now, since I want to get something of this over 2, so that I can relate it to what I know here, then we know that this one I can multiply by 1, which is 2 over what? 2. And 2 over 2 here is the same as what? 1. So we can leave this as 2, then the 2 will be here. Alright? So that we can say that only this portion will go for what? Sinh S. Only that will go for sinh S. And only this will go for what? Cos what? S. I hope you can see that. Beautiful. So this is the same as sinh 2S is going to be the same as 2 sinh S cos S. And that will give you sinh 2S. I hope it's beautiful, yeah. So the identity for sinh 2S is the same as 2 sinh S cos S. Alright, so having these identities then, it means that we can now move on and solve some questions under this part. Okay, so let me clean this side. Our first question is to find the numerical values of the expression. The first one is sinh 0. Sinh 0. The second one is tanh 1. And the third one is called -1. There are a lot of ways you can even set your own one and solve it. Alright, but all that I want you to know here is that this one is not the same as sinh S is not the same as sinh S. Okay, so you cannot just take your calculator, punch sinh S and go, thinking that it's the same thing. It's not the same thing. So having this, you know that sinh S is the same as e raised to the power S minus e raised to the power negative S, all this over 2. So what sinh 0 means is that wherever you see S, put what there? 0. So e raised to the power 0 minus e raised to the power negative 0, all this over 2. And this, you get 1 minus 1 all over 2. So here, you get 0 over 2, which is the same as 0. Alright? So that means that sinh 0 is equal to what? 0. Beautiful. Okay, so let's look at the next one. Looking at the next one, which is for tanh 1. Now we know that tanh S is the same as what? Sinh S over what? Cos S. So having tanh, and me and you also bear in mind that sinh S is the same as what? So with this, you have to go and look for what? Sinh S, which is the same as e raised to the power S minus e raised to the power negative S, all this over 2. So having tanh -1 is the same as you replacing here by what? -1. You replacing here by what? -1. Alright? So you put -1 here, what value will you get? And when you go for cos S, e raised to the power S plus e raised to the power negative S, all this over 2. When you replace the value also S of the S here by -1, what will you get? And family, when you do that, in all you are going to get times -1 to be equal to -1.313. So that is what you are going to get for that. Okay. So let's go and see some proofs. Let's go and look at some proofs regarding these identities. Some proofs regarding these identities. Alright. Oh, you have to try on the quash, okay? The quash S is the same thing. I trust that you can do it. So I don't need to worry myself. Good. So let's look at this one. Prove that A cos S minus cos square S minus sin square S is equal to 1. B 1 minus tan square S is equal to sec square S. Solution. And family, I'm going to try the first one so that you do the what? The second one. Alright, so let's see what this is going to give us. Now we know that with this, A cos square S minus sin square S is equal to 1. Right? So from the left hand side, let's use the left hand side to prove to the what? The right hand side. We know cos S to be e raised to power S plus e raised to power negative S, all this over 2. And all square minus e raised to power S minus e raised to power negative S, all this over 2, all square. That is the same as sin square S minus what? Sorry, cos square S minus what? Sin square what? S. So having this, we can write this as e raised to power S plus e raised to power negative S all square. All this over 4, because 2 square is what? 4. Minus e raised to power S minus e raised to power negative S all square. All this over what? 4. Beautiful. Beautiful. Okay. So this means that this multiplying is how many times? 2 times. So e raised to power S plus e raised to power. So e raised to power S will multiply e raised to power S plus e raised to power negative S plus e raised to power negative S, e raised to power S plus e raised to power negative S. So this will multiply the whole of that, and the second one will also multiply the whole of that. Hope you're not confused. I trust you. All this is over 4 minus e raised to power S will also multiply e raised to power S minus e raised to power negative S. Negative e raised to power negative S will multiply e raised to power S minus e raised to power negative S. And all these 2 over 4. Beautiful. So this multiply this, you get e raised to power. Let's look at something. E raised to power S times e raised to power S. You see, the base are the same. So you just add the what? The exponent. So here you get 2x plus. Now with this, know that if here is negative and you add, it will cancel. So e raised to the power 0 is the same as what? 1. So here we get 1. Down for that. Plus this also multiplying this, you also get 1 there. Plus e raised to power negative 2. Yes, negative 2. Beautiful. All this over 4. Minus e raised to power 2s. E raised to the power, that one too will give you 1. That one too will give you 1. Minus plus that gives negative 2s. All this over 4. So here we get e raised to power 2s plus e raised to power negative 2 plus 2. All this over 4 minus, here too we can also get e raised to power 2s plus e raised to power negative 2s. Alright, minus 2, all this over 4. You see what we have now is very beautiful. Alright, so now let's see what we are going to get. You can now see that all that we have here is the same as all that we have here. I hope you can see that. So what we combine is we have the same what? Denominator. So we can add this. And the negative will spread the inside. So e raised to the power 2s plus e raised to the power negative 2s plus 2 minus e raised to the power 2s minus e raised to the power negative 2s. Yeah. Plus 2. All this over 4. Okay. So having this, we can see that this will cancel this will cancel this, and we are going to get the numerator to be 4 and the denominator to be 4, getting what? 1. Therefore, our identity is proved because we are getting the final answer to be what? 1. So that is how we prove such identities. You see, it's not difficult. Make sure you try your hands on it, and in case of any problem, you send me on WhatsApp or email to me. Thank you for that. Okay, so that is that for that. Now we are going to look at the index. So I'll be back. Alright, before we go to the inverse, you see, when we go to the inverse of hyperbolic function, we go for the derivative of hyperbolic function. So now that we are done with the hyperbolic function definitions and all that, and the proofs of the identities, let's look at the derivatives of what? The hyperbolic functions. So under the derivative of hyperbolic function, let's say we have the derivative of sin s. That would be equal to what? Cos s. Why are we saying that this would be equal to cos of what? S. Let's see the proof. We know that sin is equal to e raised to power s minus e raised to power s over 2. Alright. So having this one that we have here is the same as half e raised to power s minus e raised to power negative s. Okay. So we can see that this is the same as this. So having this, when you take the derivative of e to the power s, it's the same as e raised to the power s, calculus 1. And when you take the derivative of this, you see, you will leave the whole of this, but you have to differentiate the what? The power and multiply by what? The function. So when you differentiate this, you get negative 1. When it's multiplied, here will be what? Plus. And you get it all over what? 2, because with the constant, you will not attempt it. So you can see that this one we have here is the same as cos what? S. That is why the derivative of sin s is equal to what? Cos s. In case you haven't watched calculus 1, please go back and watch. This one will give you sin s. Why are we saying that? In the same way, this is the same as half equal s plus e to the power negative s. So having this, when you take the derivative of this, you get e raised to the power s. When you take the derivative of this, you get negative e raised to the power negative s. And this one we have here is the same as sine of what? S. So that is why we have that to be that. Very good. Let's look at that for the derivative of times s. We know that times is the same as sin s over what? Cos s. Beautiful. So, if you want to take the derivative of tan s, then we have to take the derivative of this. And this is the same as what? Quotient rule. So, as we do for quotient rule, calculus 1. So, we go low, and that is for quotient rule. So, low, the high, the high. So, when you differentiate this, you get what? Cos s. Because the derivative of sin is what? Cos. Plus, so low the high minus high the low. So the high is what? Sin s. And the low, when you differentiate cos, you get what? Sin s. So low the high minus high the low, square the bottom. And the bottom is cos square s. Cos square s. So this multiply this, we get cos square s minus sin square s, all this over cos square what? S. But we know from hyperbolic identities that the numerator we have here is what? 1. So 1 over cos square what? S. And we also know from identities that this is a reciprocal identity of what? Of sec square what? S. Therefore, the derivative of times s is equal to what? Sec square s. So that is what we have for that. Beautiful. Let me give you the table of differentiation. The table of differentiation. Straightforward. 4. So this is 1. This is 2. This is 3. 4. When you take the derivative, that is the reciprocal identity of cos. Let me keep all for you again because you can get an implicit of it. So when you have sin, I'm not going to represent that by s again now, u. That means that the u can be a function, the u can be 2s plus 1 or something like that. Good. So you can get a function of sin and it is embedded with another function. So the u should be a proper one to use, which will be equal to. So you differentiate the whole of this, which is cos u. But since it's an implicit, then you get what? Du ds. Du ds. 2. Here you get cos u. The derivative of cos u to be equal to. You integrate the whole of this, you get sin u. Sin u. Then you take du ds. Don't forget that when you integrate sine, which is trig identity, when you integrate cos, you get negative sine. But in hyperbolic identity, you will not get negative. Don't forget that. You will not get negative. So that is that. 3. The derivative of tan u. Tan u will be equal to sec square u du ds. 4. The derivative of cosec u will be equal to negative cosec u times cot u du ds. Fifth one for here you get it to be negative, here to be negative. In fact, the one that is, you get it to be negative. Du ds 6. Alright, so that is the hyperbolic differentiation. Hyperbolic differentiation. Okay, so now we can try our hands on some questions. We can try our hands on some questions, and trust me, you will love it. Alright. So let's try our first question. Y is equal to cos squared 3t squared plus 2. Find dy ds. Alright. Having this question is hyperbolic what? Differentiation. So, first of all, bear in mind that dy ds is going to be the derivative of the whole of this. dds of, watch. Now this square that we have here, for instance, if you have sec square 2x is the same as the square coming here. So always don't forget that. So having this, in the first attempt, which idea or which techniques in differentiation will you go by? Calculus 1, please. Don't be thinking that this is a product rule. Because this one we have here is the same as cos 3t squared plus 2. Then the square will come here like that. So this is a general power rule or chain rule. So that is what we are going to apply here. And that you are going to get general power rule. The power will multiply the whole of this. Cos 3t squared plus 2. Then you subtract 1 from it, so here will be 1. Then you take the derivative, in case you haven't forgotten. You take the derivative of the inside, and the inside is from here up to here. The inside is not only here, but the whole of this. So that is cos 3t squared plus 2. Cos 3t squared plus 2. And that is that. Very good. Let's continue and see what that is going to give us. So the whole of this will repeat. The whole of that will repeat. And if you want to differentiate this one to differentiate cos, you get what? Sinh. And when you get sinh of this, then you take the derivative of the inside here, which is 3t squared plus 2. Hope you can see from there. Very good. And that is what you are going to get for that. Let's continue. So you get 2 cos 3 plus 3t squared plus 2 multiplied by sin. Hope you are following. 3t squared plus 2. Alright? And when you differentiate this, you are going to get 6t because that will be 7. Just 6t. And finally, you are going to get a result of the 6t will multiply this and you get 12t cos 3t squared plus 2 Good. Beautiful. So that is going to be the final results for that. So that is what the derivative of this is going to give us under the hyperbolic function. Let's try, or you will try on example 2. If y is equal to cot 2x, find dy dx. As I said, if you haven't watched differentiation in calculus 1, go and do it, because here it's all about what your differentiation. Question: is this a product rule, chain rule, or what? What do you think? Huh? Let me assist you some more in that question. Alright, so this is the cause of this. What we have here, you may be thinking it's a product, but unfortunately it's not. The reason is that the cos 2x we have here, the whole of what we have here, is the angle representing cot. Yeah, that's angle representing what? Cot. So it's like cot of what? Theta. So the theta is now represented by what? Cos of what? 2x. So this is a chain rule. This is purely what? A chain rule. But not product rule. Because you are not having something like x here, then you'll be thinking that it's a product rule. There is the angle for this. So please, it's not a chain, a product rule, but rather what? A chain rule. So let's solve this by a chain rule. So divide dx will be equal to when you differentiate, forget about the angle now. When you differentiate cot x, what will you get? And that is going to give you, let me go back to my formulas. That's going to give you negative cos square what? S. But now the S, that's the angle, is represented by cos 2s. Take your time. Chain rule. So differentiate the whole of this, you get this. So there is the cosec square s, and the s is the angle for this. Then you take the derivative of the inside. The derivative of the inside, which is cos 2s. Which is cos 2s. Beautiful. So here you get negative cos square cos 2s. Then the derivative of it. You know that the derivative of cos, you forget about this angle. Cos s is sin s, and the s now is what? 2s. Then the derivative of the inside, this is a chain. The derivative of the inside of 2x, and that is negative cos square cos 2x, and this will repeat. What you have here is what? 2. So we get negative 2 beautiful. So that's the final answer for that. Wonderful. So that is that. You can try your hands. There are a lot of questions. There are a lot of questions in your books like Stewart. You get a lot of questions in it. And also when you visit our Math Expert app on Google Play Store, when you go there, just type Math Expert on Google Play Store. We have materials there for you, which entails with a lot of questions and sometimes solutions are also attached to it. You will get that. So I'll be back with an inverse functions, an inverse hyperbolic functions and its derivative, and you will have it. Alright, thank you. Alright, so that is inverse hyperbolic functions. So the sine inverse and its the functions and its domains. So these are the functions and these are the domains. The graphical representation, you got the graphical representation for what? Sine inverse. That is from what? Negative infinity to what? Positive infinity. So this doesn't end. It goes continuous like that. It's a continuous functions. And also we have cos inverse. The cos inverse, you can see that it's close at what? 1. But infinity, it goes to positive infinity. So this goes to what? Positive infinity. That is for cos inverse. And for tangent inverse, the tangent inverse, you can see the domain that negative 1 and what? 1. And that one too. Yeah. So that one, we have the negative 1 and the 1, and it goes what? Infinity. And this one also goes. But this goes what? Positive infinity, and this goes what? Negative what? Infinity. So that's how. That is what. Sorry, not negative infinity or what? Positive infinity, but it goes straight. But you see, there's an asymptote here, so it can't cross to this side, and there's an asymptote here, so it can't cross to this side. So that's how that one is represented. All right. So let's look at it as logarithms. As logarithms. So let me take this side. As logarithms, 1, we have sinh inverse of s to be equal to the ln of s plus square root of s squared plus 1. And the domain here is that s belongs to what? R. That's s belongs to all red squares. And we have already given that 2. We have cos inverse of s is equal to the ln of s plus square root of s squared minus 1. And the inverse for tangent inverse of s is half ln 1 plus s 1 minus s. Take note of these identities or formulas very well. It is very, very, very important, and we are going to use it. All right, very good. So that is that for that. That is that for that. Now, this is just the inverse functions, sine inverse, cos inverse, and what? Tangent inverse. Good. So what about 8 reciprocal what identities? For instance, 4. If you want a reciprocal for this is cosec sine inverse of s. Cosec sine inverse of s will be, you see, we are saying that each reciprocal what identity. So the angle here is what? X. So it's only the angle. It's only the angle that will be what? Changing. So the x here will now be 1 over s plus square root of 1 over s squared. Now 1. Each reciprocal is the same as what? 1. And that will give you that. And when you come to 5, what is sec inverse of s? This one will be ln 1 over s plus square root of 1 over s squared minus 1. And that is that. And the 6th one is tan inverse of s. And that's going to be half ln of, now here, 1 plus 1 over s. It's like all the angle will be, you'll be taking reciprocal of it. Sorry, minus 1 over s. So that is tan inverse, sec inverse. Most of the books will not give this to you, but you need it, alright? That is how you are going to get it. So let's try our hands on these questions. Let's try our hands on these questions. You have what? Sine inverse of 3. How are you going to do it? We don't even have sine on the calculator, neither its inverse. So what we do is that, but we know that, but sine inverse of s, and the s now represented by what? 3, is ln of s plus 1. That's what we have here. S plus square root of what? S squared plus 1. Is that also? So wherever you see s here, you put what? The 3. So you get ln 3 plus 3 squared plus 1. And that is going to give you ln 3 plus square root of 10. Alright, so that's what we are going to get for that. So this is going to be the approximate value for that. You can also leave it in decimals, it's up to you. So you can try on 2 sec inverse of this. So that's why you need the reciprocals. That's what we have here. So just set the value of this into it and you get your answer and go your way. So just do substitution. Whenever you see s, you put 1 over square root of s there. So do it. Yeah, so when you do that, your answer is going to be equal to have, ln square root of 2 plus 1. So that's going to be your results for that question. Keep on trying, okay? You can also, you have all the identities, so you don't have any problem. You can also try your hands on cos inverse of 3. You can also try your hands on cosec inverse Here you get half ln 2. With this you get half ln 2. And with this you get you get ln 2 plus square root of what? 2. So ln into bracket square root of what? 2. So that's what you're going to have for that. Alright. So now that we have looked at the functions and its inverse and all that, let's go to the derivatives. Let's go to the derivatives and you will have it. Alright, let's look at the derivative of inverse hyperbolic what? Function. Alright, so like as what we did at first, let's first look at cos inverse of x. We know that cos inverse of x is the same as ln of what? S plus, that is the ln of what? X. Good. So if you want to take the derivative of cos inverse, then let's say that let's first take the derivative of both sides. And when you take the derivative of both sides, that means that we want the derivative of cos inverse of x to be equal to the derivative of s plus square root of s squared plus 1. Good. So I've forgotten the ln s. Good. So calculus 1. Go back and watch it. So calculus 1 is calculus 1. Because of the ln here, 1 over s plus square root of s squared plus 1. Sorry. You're supposed to be minus. That is cos. Minus. Good, minus. So that would be 1 minus what? The inside of the ln times the derivative of the inside. And the inside is s plus s squared minus 1. So this is what? Calculus what? 1. Alright, so with this you are going to get 1 over s plus s squared minus 1 multiplying by derivative of this is 1 plus derivative of this. Don't forget that the derivative of this, you don't repeat that step again. So this is like s squared minus 1 over half when the root what is ignored. So you get alright, so now let's see. So here, what rule is that? General power rule. So half will multiply x squared minus 1. Then you subtract 1 from the what? From the power. And you get negative half. Then you take the derivative of the inside. And that is going to give you 2x. Very good. Algebra. The algebra 2 must be good. S plus s squared minus 1. Here we are going to have this to be 1 plus, don't forget your algebra here, 2s over, and this one will go down, so 2s squared minus 1. And this will cancel this. So we are going to 1 over s plus s squared minus 1. Please, this is not calculus, this is just algebra. Multiplying by 1 plus s over s squared minus 1. I hope you can see that. Alright, so having this, then we are going to manipulate this with algebra. We get s plus s squared minus 1 multiplied by 1. Now the 1 here, I want to achieve the same common what? Denominator. So the 1 here, because I want to achieve the same common denominator, I will multiply by a set plus s over. You see, this is the same as the 1 here. That is mathematics for you. S squared minus 1. Good. So having this, we are going to get 1 over s plus s squared minus 1 multiplying by s plus, since they are having the same one denominator, so you add the numerator. S squared minus 1, all this over s squared minus 1. Beautiful. So you can see that this one is going to cancel this. So we are going to get 1 over square root of s squared minus 1. Therefore, the derivative of cos inverse of s will be equal to that. Beautiful. Alright, so that is that for that. I hope you are loving it. Now, we have another alternative way to get this, and let's see how we are going to do that. We have another alternative way. In case you don't like this one. If y is equal to cos inverse of, if y is equal to cos inverse of x, then here we can take cot of both sides, and we get cos y being equal to, and when we take cos of both sides, it will ignore the inverse, so you get it to be x. Beautiful. And when you get this side to be x, what we do here is that we take the derivative of both sides. And when you take the derivative of this cos y, the derivative of this x. Now, this is going to give you what? Sin y. And this is going to give you what? 1. Beautiful. Beautiful. but we know that cos square y, since the angle is y, minus sin square y is equal to what? 1. And since this is equal to 1, we can make sin square y the subject to be, send this one here, this one here, so we get cos square y minus 1. Beautiful. So to get sin y, we take square root of both sides, and we get square root of cos square y minus 1. You will have it. So that is the alternative way. The alternative way. So now that we are here, by substitution to this side, by substitution, we can say that, okay, so by substitution, we can say that the sin y is the same as cos square y minus 1 is equal to 1. Okay? Is there a mistake? There's a mistake somewhere. I see where the mistake is coming from. Don't worry, I will correct it. Alright, now when we are taking the derivative of this, note here that this is an implicit word differentiation. Alright. Please, the mistake I had here is that what we are doing is that we are finding the derivative of cos inverse. So we first take cos of both sides, and that ignore the cos inverse. So here is x. Then you take the derivative of both sides. But when you are taking the derivative of both sides, here is as respect to x. But this function is as respect to what? Y. So it becomes what? Implicit what? Differentiation. So we should have, after this, we shouldn't have just equated to 1, but rather repeat y ds to it. So that is what we didn't want to do. Alright. So everything here is correct, and therefore, since that sin y is equal to this by substitution, you are going to get this for that. Alright. So to get to make dy ds the subject, we take the what? We divide this side by what? Both sides. We divide this by both sides, and we're going to get 1 over this. Alright. But bear in mind that we have s to be equal to what? Cos what? A. So here we put cos of y, and here it's like this is cos squared. Alright? This is cos squared, but this cos squared is the same as that. So we put cos y to be equal to what? X. And we get our final answer to be what? That. So this is the derivative of cos inverse, tan inverse, and cot inverse. Here we are representing it by u but not x, because we can get an implicit what? Function. We can get a function, for instance, let's say cos 2x squared plus y. Sorry, cos 2x squared plus x. Now, dealing with such case, cos inverse of 2x squared plus 1, you cannot represent it by what? X. You have to represent the inside of it by what? U, so that the u will come here, and then you take the derivative of what? The u, and you multiply by it. Let's look at an example, and you will see what I'm talking about. So, our first example. If y is equal to e raised to the power s e raised to the power s, such inverse of 3s. Alright, so having a question like this, how are we going to solve it? Is it too big? Alright, let me go for Alright, let's take this as our first example. So having this, you know that here dy ds is going to be equal to, first of all, we have to put the inside here to be equal to what? U. So we let u to be equal to 3x squared. So du ds will be equal to 6x. Alright, now we now have y is equal to cot inverse of what? U. Alright. But dy dx of cot u is equal to what? 1 over square root of u square minus 1 du dx. Du dx. Beautiful. Since we know that we have du ds already here, we also have u here. So by substitution, we get 1 over the square root of 9x to the power 4, because we have 3x squared. So the square of 3 gives 9, the square of x squared gives x to the power 4. So we get minus 1. Good. So that's what we have for this. Then we multiply by du dx. Du dx is what? 6x. And we get 6x over square root of 9x equals 4 minus 1. So that is the derivative of cos inverse of 3x squared. Beautiful. Beautiful. Let's look at our second example. Okay, I'm coming. Alright. So now let's look at our second example. And in our second example, we have y to be equal to tan inverse of what? Sin x. So the argument or the angle here is what? Sin x. It's very important to note that. And we have to find the y dx. Very good. So we know that the derivative of tan inverse of u is equal to 1 over 1 minus u squared times du dx. So we are going to let our u to be equal to what? Sin s. Then du dx will be equal to cos, not cos, cos s. Alright. So by substitution to this, we can have 1 over 1 minus what? Sin x squared times du dx, and du dx is what? Cos x. Very good. So here we get 1 over 1 minus sin square x times, and when this multiplies this, we get cos what? X. But we know that 1 minus sin square x is equal to cos square what? X. So here we get cos x over cos square x, and one of these will cancel this, we will get 1 over cos what? X. Very good. So that is the derivative, that's the result of the derivative of what? Tan inverse of what? Sin x. Hope you are loving it. It's very simple. Alright. So let's look at another example here, and it may be our last example. It may be our last example. It may be our last example. Example 3. We have, okay, so the example 3, we have y is equal to, if y is equal to s times inverse of s plus ln square root of 1 minus s squared. Alright, and we have to find dy what? Dx. Okay, so having this question, don't worry, okay? You see, we have the function of y in terms of what? X's. We can take the derivative of each term. Alright, so taking the derivative of each term, when you differentiate y, you get what? Dy dx. Very good. Now, you have to take the derivative of what? The s times inverse of s, then you close it. Then you come and take the derivative of what? That's why, in case you are forgetting your calculus, go back and revise, because All these things are calculus. All these things are calculus 1. So here to we get square root of what? 1 minus s squared. Square root of what? 1 minus what? S squared. So now, let's go. Here, we can see a product rule here, right? We can see a product rule here. So we go by, leave this one, differentiate tangent inverse of s. And what will you get? What are you going to get for that? You're going to get 1 over 1 minus s squared. No more u squared because du ds. If you set u to be s, du ds is 1. And this will not affect anything. So it's just 1 over 1 minus what? S squared. Plus. So leave this one, take the derivative of this. Now, you have to differentiate what? The s. You get 1. Then you leave tangent inverse of what? S. Plus having this. Note that the square root is what? Power what? It's like 1 minus s squared power half. So half come here. Oh, sorry. I forgot to bring the limit. And it's very, very, very important. So here we get d ds of ln square root of 1 minus what? S squared. So since we have the ln there, you know your calculus 1. So 1 over square root of 1 minus what? S squared. 1 over the square root of what? 1 minus what? S squared. Or 1 over the what? The inside of the ln. Then you take what? The derivative of the what? Of the inside. And the derivative of the inside is not just this. Sorry, it's not just this, but rather include with what? The square roots. Very good. Beautiful. So now this multiply this, we get s over 1 minus what? S squared plus this multiply this, we get what? Tangent inverse of what? S plus repeat this one, 1 over square root of 1 minus what? S squared multiplying by this one. We can rewrite this as what? This. So we get half here. We repeat the inside. We subtract 1 from it, we get negative half. Then we take the derivative of the inside. And the derivative of the inside will give you negative 2x. Very good. Let's continue. You have to be a good in your calculus, okay? So the dy ds is going to be equal to s over 1 minus what? S squared plus. Now the tangent inverse. I'll come back to it later. So tangent inverse of s plus here we get 1 over square root of 1 minus what? S squared. This may be our last example. Alright, where are we? So what we have here means that algebra. This we are going to get negative 2s over, note that this is multiplying this. And here we get 2, then down here, 1 because of this negative half, so we go down. 1 minus what? S squared. So this is one thing that we are talking about. Okay. So here you can see that this will cancel this. Yes. Yes. That will. So that will cancel that. So we get s over 1 minus what? S squared plus, please, you know tangent inverse. Tangent inverse is the same as what? You know that tangent inverse is the same as half ln 1 plus s 1 minus s. You know that, so you have to write it so that you get rid of the hyperbolic function. Plus, what we have here is 1 over square root of 1 minus what? S squared. Multiplying by what is left here? We are left with negative s over square root of s minus what? S squared. Ooh. 1 minus s squared. Beautiful. Algebra. We are still manipulating under algebra. Half 1 plus s, 1 minus s, plus this and this, we get negative s over this and this. That will get rid of the square root, so you get 1 minus what? S squared. Beautiful, don't get tired. Let's continue. So here, we can now combine. Yeah, you know that here will be negative, okay? So the negative of this will come here. And you see this can cancel this. Clearly, you can see that this will take away what? This. And therefore, we'll be left with what? Tan inverse. If I should have maintained it here, we're going to get tan inverse. And then that tan inverse is the same as this. So here we get half 1 plus s, 1 minus s. So that's going to be the end result. Or tan inverse of what? S. So in case, let's say, OBJ question and you don't see this, and you see this, you go for it. Thank you all, and make sure you take your time. In case you don't understand anything, don't worry. Just pause the video. You are with the video that you can manipulate it. You can even, in case you are watching it on your, in case you have downloaded it from YouTube and you are watching it on your laptop, you can even reduce it to go slow as what you want it to be. Okay, so don't worry, you can play back, and in case of anything that you don't understand, you can WhatsApp me with your questions and I will attend to you. Thank you all, and we will be back again. Bye bye. Let me give you some questions for you to go and try, okay? As a student, you have to solve a lot of questions, alright? Alright, so these are your try. Just go and try all these questions and you will have it. And if you are able to come out with the solutions to all these questions, it means that you really have the concept of what I have been teaching since day one. Alright, thank you all and see you for. Now, in our next video, trust me, we are going to start with calculus 2. Now, I'm going to start with calculus 2. That is integral calculus. All that we have been doing here is the leftover in calculus 1. Right? That is hyperbolic what? Differentiation and the hyperbolic differentiation under calculus what? 1. Even though you will see it in the calculus 2 playlist. But you will also be doing integration of hyperbolic function. So make sure, you see, as we are going through, you see that you will be in need of calculus 1 very much. So make sure you go and revise. And I will see you for integration. Bye bye.